Hello, this is Sigma Bob. In this video, I will be discussing problem 19 from the AMC 10 2024B. We will carefully examine the problem statement, identify the key idea required for its solution, and work through the steps in a clear and systematic way. Let's get started. Here is problem 19 from the AMC 10 2024B. In the following table, each question mark is to be replaced by possible or not possible to indicate whether a non-vertical line with the given slope can contain the given number of lattice points both of which coordinates are integers. How many of the 12 entries will be possible? Determine which combinations of slope type and number of lattice points are possible by examining the properties of horizontal rational slope and irrational slope lines. Pause the video here if you'd like time to solve the problem yourself. Now let's go through the solution. First, consider lines with zero slope. A horizontal line contains no lattice points if its y-coordinate is not an integer. If its y-coordinate is an integer, then every integer x value is also a lattice point, so it cannot contain exactly one or exactly two lattice points. However, it can contain more than two lattice points. Now consider lines with a non-zero rational slope. Such a line can contain no lattice points, for example y equals x plus 0.5. If it passes through one lattice point though, the rational slope causes the pattern to repeat, so the line must pass through infinitely many lattice points. Therefore, exactly one and exactly two lattice points are impossible, while more than two is possible. Finally, consider lines with an irrational slope. A line can contain no lattice points if its y-intercept is not an integer, and it can contain exactly one lattice point if its y-intercept is an integer. However, it can never contain two or more lattice points, since the slope between any two lattice points is always rational. This gives two possible cases for each of the three slope types, with a total of 2 plus 2 plus 2 equals 6. Therefore, the final answer is choice C, 6.